Hello, so in today's class we will see the next theorem on Ramsey numbers. So the theorem states that for all integers PQ greater than or equal to 2, so if R of P minus 1 Q and R of P Q minus 1 are even, then R of PQ will be less than or equal to R of P minus 1 Q plus R of P Q minus 1 minus 1. So in the last theorem we have seen for all integers P and Q greater than or equal to 2, R of PQ is less than or equal to R of P minus 1 Q plus R of P Q minus 1. So we will P-general principle use our result prove. Now here if provided these two are even, then we need to show that R of PQ is less than or equal to R of P minus 1Q plus R of P Q minus 1 minus 1. So we will use the ideas of the previous theorem also. നമ്മൾ P-general principle previous theorem use ചെയ്തിട്ടുണ്ട്. അത് നമ്മൾ ഇവിടെ use ചെയ്യും. Okay. So let us see the proof. Now let me take m equal to r of p minus 1q plus r of p q minus 1 minus 1, and let km be an m-clique in which, so there will be total MC2 edges, so in which the MC2 edges are colored blue or red. Okay, so we are taking m to be the number r of p minus 1q plus r of pq minus 1 minus 1, and we are considering an m-clique. So in an m-clique there will be a total of MC2 edges. M-clique എന്ന് പറയുമ്പോൾ that will be a complete graph. So in complete graph, so total number of vertices will be m. അപ്പോൾ the number of edges will be, so you need to choose any two vertices at a time. So the number of edges are going to be MC2. The graph is colored randomly with two colors, blue or red. Now let us use the P-general principle here. So therefore it is in the form k1 plus k2 minus 2 minus 1. So generalized P-general principle നമുക്ക് use ചെയ്യാവുന്നത് പോലെയാണ്. Okay. So fix an arbitrary vertex W in Km, then W is incident with m minus 1 edges. So if you take a random vertex in Km, so vertex ആയിട്ട് incident ആയിട്ട് m minus 1 edges ഉണ്ടാവും. Now we need to prove that, so we need to prove that r of pq is less than or equal to m, where m is r of p minus 1q plus r of pq minus 1 minus 1. R of PQ less than or equal to M means that is any coloring of Km. So Ramsey number P of Q must be less than or equal to M. So any coloring of Km with blue and red contains a P blue click or a red Q click. So this is what we need to prove. So R of PQ less than or equal to M means, so in any coloring of Km, there will be either a P blue click or a Q red click. And now let us use the previous theorem. The previous theorem we prove R of PQ is less than or equal to R of PQ minus 1 plus R of Q P minus 1 Q. So if the number of blue edges are greater than or equal to R of PQ minus 1, അങ്ങനെ ഒരു ഗ്രാഫിൽ P ക്ലിക്കോ അല്ലെങ്കിൽ Q ക്ലിക്കോ ഉണ്ടാവും. അതുപോലെ if the number of red edges are greater than or equal to R of P minus 1 Q, such a graph will contain either a P click or a Q click. Okay. അപ്പോൾ ഈ രണ്ട് കേസിലും so when you have R of PQ minus 1 blue edges or R of P minus 1 Q red edges, in that case R of PQ will contain either a P click or a Q click. നമുക്ക് വേണ്ട ക്ലിക്ക് അതിൻ്റെ അകത്ത് ഉണ്ടാവും. So if this is the case, our condition will hold. Okay. ഇനി നമുക്ക് എടുക്കേണ്ടത് നമുക്ക് ഇതിലും ചെറിയ edges ആണ് വരുന്നതെങ്കിൽ, so if the number of edges is less than this, we will show that it is not possible to find a P click or a Q click. So by the previous theorem, so if R of P minus 1 Q or more edges are blue, then by the previous theorem, there is either a blue P click or a red Q click in Km. So that is by the generalized P-general principle. And similarly, likewise, if R of PQ minus 1 or more edges are red, then we are again through. So in that case also there will be either a P blue click or a Q red click. Now let us consider അപ്പം ഇങ്ങനത്തെ ഈ കേസ് എടുത്തു കഴിഞ്ഞാൽ, so if the number of blue edges are greater than or equal to R of PQ minus 1, red edges are greater than or equal to this, or blue edges are greater than or equal to this, ആ കേസിൽ നമുക്ക് KM ൻ്റെ അകത്ത് എപ്പോഴും P ക്ലിക്കോ Q ക്ലിക്കോ ഉണ്ടാവും. So in that case R of PQ will be less than or equal to M. So this is what we need to prove. അപ്പോൾ ഇത്രയും edges അല്ലെങ്കിൽ this or more number of edges. Now let us look at the case where when you have an edge R of P q minus 1 minus 1 അല്ലെങ്കിൽ r of p minus 1 q minus 1. അപ്പം ഈ എഡ്ജ് വരുന്ന കേസിൽ നമുക്ക് less than or equal to m ആണോ എന്ന് നോക്കാം. So we will show that this is not possible. അപ്പോൾ r of p q minus 1 or more edges അല്ലെങ്കിൽ r of p minus 1 q more red edges വേണം. Then only r of pq will be less than or equal to m. So that's what we are going to prove. So now consider the case when there is exactly r of p minus 1 q minus 1 blue edges and r of p q minus 1 minus 1 red edges. അപ്പോൾ ഈ കേസിൽ നമുക്ക് p ക്ലിക്കും q ക്ലിക്കും ഇല്ലെന്ന് നമ്മൾ പ്രൂവ് ചെയ്യും. അപ്പോൾ ഇതിനെക്കാട്ടിലും ചെറിയ നമ്പർ വന്നു കഴിഞ്ഞാൽ ഡെഫിനറ്റ്ലി അത് ഉണ്ടാവില്ല. സോ we will consider the case when there is exactly r of p minus 1 q minus 1 blue edges and r of p q minus 1 minus 1 red edges incident with each vertex v in Km. So we claim that this is not possible. So we claim that this is impossible. So നമ്മൾ ആദ്യം പ്രൂവ് ചെയ്തതാണ് r of p minus 1 q or more edges blue അല്ലെങ്കിൽ r of p q minus 1 or more red edges വരുമ്പോൾ r of pq will be less than or equal to m. Now we are considering the case when the number of blue edges is exactly this and the red edges is exactly this one. So we'll claim that this is impossible. Now if this is the case, അപ്പോൾ നമ്മൾ പറഞ്ഞതാണ് number of blue edges incident with any vertex v is r of p minus 1 q minus 1. ഇനി നമുക്ക് km ൽ total m vertices ഉണ്ട്. So let us count the total number of blue edges in the graph km. So in this case then the total number of blue edges in Km would be, so with each vertex there will be r of p minus 1 q minus 1 blue edges incident. ഇനി ഓരോ എഡ്ജും നമ്മൾ ഇങ്ങനെ എടുക്കുമ്പോൾ twice കൗണ്ട് ചെയ്യുന്നുണ്ട്. So the total number of blue edges are going to be m by 2 into r of p minus 1 q minus 1. Now we are given that, now let us use the given condition. So we are given that r of p minus 1 q and r of pq minus 1 are even. So therefore we have taken m as r of p minus 1 q plus r of p q minus 1 minus 1. So m equal to this. So these two are even. So minus 1. This is going to be an odd number. So and again r of p minus 1 q minus 1 is also odd. So therefore m by 2 into ഈ രണ്ടും odd ആണ്. അപ്പോൾ അതിൻ്റെ പ്രോഡക്റ്റ് എടുക്കുമ്പോൾ നമുക്ക് odd ആയിരിക്കും വരിക. So m by 2 into r of p minus 1 q minus 1 is not an integer, but this actually counts the number of edges, so which is not an integer, so that is not possible. So therefore we get a contradiction, since the number of edges is not an integer. So therefore it is not possible, so our assumption is wrong. So therefore it is not possible to have R of p minus 1 q minus 1 blue edges and R of p q minus 1 minus 1 red edges. So therefore ഇപ്പോൾ ഇത്രയും എഡ്ജസ് വന്നു കഴിഞ്ഞാൽ നമുക്ക് ഒരു ബ്ലൂ ക്ലിക്കോ റെഡ് ക്ലിക്കോ കിട്ടുന്നത് പോസിബിൾ അല്ല. സോ therefore there is at least R of p minus 1 q blue or R of p q minus 1 red edges. So therefore if this is the case, then R of PQ. അപ്പോൾ ഈ കേസിൽ the previous theorem വെച്ച് R of p minus 1 q blue edges or R of p q minus 1 red edges ഉണ്ടെങ്കിൽ you will have a p click or a q click in it. So then R of pq will be, so km ൽ നമുക്ക് p click or q click ഉണ്ടാവും. So R of pq will be less than or equal to m. So that implies now m is so we'll get R of pq minus 1 plus R of p minus 1 q minus 1. So that is the proof of the theorem.